Hey, welcome everybody. I'm working in a pen test department. So we're pen testing web applications, we're pen testing IT infrastructure, and maybe sooner or later we're gonna test blockchain. Since you know blockchain is becoming kind of a thing, people are running around and telling, hey, blockchain might be useful, Bitcoin is using it, and it might be useful for like supply chain, for notary, for whatever use case you can imagine, blockchain is a solution. And what they tell you as well is that blockchain is not only a solution, it's the solution. Why? Because it's secure, it's immutable, and it's just awesome. And as a security guy, you're wondering, is it really secure? And then there are headlines like this. There are hacks, multi-million-dollar hacks. Money is getting stolen all the time, pretty every week. They're stealing money in like budgets that you couldn't imagine. It's not about privacy, it's just about pretty much just money that's getting stolen. And you wonder, like, is this technology really secure? And when you dive deeper, they're not hacking the blockchain. So this is kind of boring. This is like application hacks. They're hacking your wallets. They may be hacking your database. They may be hacking your framework. They may be hacking just a simple WordPress, whatever. So this talk is not about dollar Bitcoin hacks, okay? This talk is about a blockchain protocol. So if we go a step further the application, there's a comparison simplified. On the left-hand side is the web. There's the application layer, which is pretty big, and you all might be familiar with that. There's like the Googles and the Facebooks and the Amazons we all know. And they make up the big application layer on top of the internet protocols. They don't even have logos. They're like pretty basic layers that exist for long term. And on the other side, we've got a blockchain. And in the application layer, you might use that hopefully every day. Whatever, there's Coinbase, there's Electrum, there are lots of wallets and exchanges and services that utilize the blockchain. And down there is the blockchain. So why is the one square way bigger than the other? That is because the value captured and the value generated can be compared like this. The value generated in the web applications, the value captured, the guys who take the money home in the web is the Googles and the Facebooks. The money making and the money generated in the blockchain world is a protocol level. At least this is what is the vision. Like the blockchain is being the web 3.0, and the blockchain is gonna disrupt everything. So I was thinking, let's hack the protocol and not just the boring applications on top of that. So I was having a look at the blockchain protocol, and I was having a hard time. Like, what is the blockchain protocol? There are a lot of them outside there. And these are not altcoins. These are not just simple forks of Bitcoin. These are not like taking the Bitcoin repo and rebranding it. These are like proper blockchain frameworks, blockchain protocols. And they are trying to solve all pretty much the same problem. So there is no such thing as the blockchain protocol. And so I was wondering, are there any standards? In the web, of course, you might know the RFC standards defined by the Internet Engineering Task Force. And they're like pretty technical standards. And you can implement them the way you want, and that's fine. And you can say, hey, you implemented it right or wrong. And blockchain is a little bit different, since I grant, yeah, that's a new technology, but still there are like no proper defined standards. No RFC exists for blockchain technology. There are those white papers. Next step is the yellow paper. There are community-defined standards like the BIP, the Bitcoin improvement proposals, Ethereum improvement proposals. There are lots of well-documented wikis where technical descriptions are written down, there are documentations, and usually there's a reference implementations. But that's not what a blockchain standard should look like. So how can I hack the blockchain? So what is the point I'm going for? So first I was trying to make sense out of all this, and I'm hereby proposing a standard to categorize blockchain, and it looks kind of like this. There is a consensus design, a transaction design, and a block design, and those make up the blockchain design. And each of those primitives, those design primitives, they have some subcategories, some specifications in there, and defining on how you put those parameters, an attack vector will work or will not work. So for the consensus design, you get a consensus algorithm. You might know proof of work, proof of stake, proof of authority, whatever. Node authentication, is there any handshake? Is there any encryption between the peer discovery? How's that working? Governance is described as how is the code maintained, who is the maintainer of the project, and transparency is the public permissionless or the private and permissioned blockchain. And the transaction design is what is called a chain code, and it could be Bitcoin script. This is like Ethereum bytecode, and this is like, are the transaction anyhow programmable? And then there's the cryptographically aspects of the transactions. So how is the transaction executed? And how can I execute any transaction? And the block design is actually the data structure. So how are the blocks stored in local nodes? What is the block time between the blocks, which includes the difficulty? The coin supply, is there any generic token on this blockchain? And tokens refers to, can a user generate tokens on this blockchain? So this is still kind of boring. What I wanted to add is like application design is not a matter of fact in this kind of characteristics. So the characteristics of each protocol would look like this. We got some kind of frameworks, we got the design primitives. So we look at the characteristics of this protocol, and we see proof of work, no peer authentication, is decentralized and is permissionless. Okay? I guess you get the idea. You fill out all the characteristics for those blockchain frameworks, and then you got kind of an overview of the landscape. That's just taking the state as it is. That's fine. So, next step. You got some blockchain protocol attack vectors. And they're all well described, and they're defined, and they work on one or the other blockchain framework. But why do they work? And what do I have to change so that they don't work anymore? So I just take an example, like a 51% attack is an attack where you need the majority of computational power. And there's the blockchain, block 0, block 1. Then the attacker takes one block and manipulates it in any favor, so that usually he has an advantage, like he's changing any transaction. And afterwards, the chain is getting mined block after block. And eventually, since he has more computational power, his chain is getting the longest and is getting the truth in the network and is getting accepted by other nodes. So the conditions for this attack to work is that the network is permissionless and that it utilizes proof of work consensus algorithm. So I would call this consensus design attack. Okay? Next example would be a transaction malleability. Transaction malleability, really briefly explained, is inside a transaction, there's something called the script, signature, and a public key. And this all gets hashed, and you get a transaction ID. Okay? This transaction gets published to everybody in the network. Every node has this transaction. He can take it and modify it. Modify it in a way that it's still valid, but since it's modified a little bit, the hash value changes. This is transaction malleability. And the design conditions for this attack to work is that you need to have chain code in your blockchain, and you need to have a transaction signature. So I would call this a transaction design attack. The last example is a spam attack. Up there you got a transaction mempool. The transactions coming in, getting processed into blocks, and the blocks are getting full with transactions. Okay? So, block after block. Now the spam attack works like this, like you might know from email. I'm just pushing a lot of cheap transactions into the mempool, and the mempool is getting full. But, as you might notice, the blocks are not getting fuller. Blocks stay the same, block after block. And in Bitcoin it's roughly 10 minutes. Every 10 minutes, a block with the same amount of transactions. So the conditions for this design is how is the block time and how is the data structure inside these blocks. I would call this a block design attack, okay? So what do we do with that? Okay, fine enough, we can categorize the blockchains, we can categorize the attack vectors, and attack vectors are categorized like this. We got Ethereum, transaction design. There are all possible transaction design attacks, and there is a chain code exploit, what I would call. This, for example, is the DAO hack, would be a chain code exploit, and a botnet via chain code is actually a quite fancy attack. You could ask me later for that if you want. So those would work for Ethereum. And you can check out the whole list on this GitHub down here if you want. Yeah, and you can also fill out the whole list for all frameworks, which attack works in which framework. And the reason why I'm telling you this is, can you hack blockchain protocols? Yes, you can. Is this a problem? Since I've told you in the beginning that all applications rely on protocols, this is a problem. And since we are here to talk about individual freedom and crypto anarchy and crypto freedom, and blockchain might be a way to go with that. This is an even bigger threat to that vision, to that idea. And so I would give it definitely a yes. So what can we do about that problem? My answer to that is give it any kind of a standardization and give it a major approach to security research. And I've seen a lack of security research in that field, and I urge you all to give it a push and not just say that security by design is something that blockchain inherits. So there is no standard for blockchain security just yet. So this urgent call is going to all of you guys. There is a GitHub out there. You can collaborate, and there is no standard yet. Nobody's made a real effort to standardize anything. I would like to give a shout out to all of you guys. Collaborate and create something we can build the value on properly, and yeah, make the next step in the blockchain evolution. Thanks.
Do we have questions? Somebody? Yeah.
So my question is, how is the Bitcoin network going to be secure when the block reward goes away?
how is the Bitcoin network secure when the block reward goes away? Well, that's like an economical attack, I would say. And so that is more like a political question, right? Not a real technical question.
I suppose. Well, I mean, the attack cost will be the sum of the transaction fees, right? Which will be probably quite low. So doesn't that mean that Bitcoin will be quite easy to attack in the future?
I would say it lowers the attack cost, like I said, definitely. And so the security goes down as well. And that's not a good idea to do that. Who is planning to do that, actually?
I mean, the reward halves every 4 years, so in 40 years it'll be like 1,000 times less, in 80 years it'll be 1 million times less, so it'll be essentially zero in the long term.
Yeah, that's correct.
So
I guess the hope is that by then the transaction fees goes up or Bitcoin will be more valuable.
I don't think Bitcoin being more valuable will make a difference because the transaction fees will be roughly the same because, you know, people complain when it's $2 and you're going to have a finite number of transactions. I think maybe we're going to have to change the consensus, do you think? I don't know.
So, see, Bitcoin is not only like a technical concept, it's an economic concept and the economic building. And up until now, the economic incentives are set right, and it's still working. And it might be happen that in one point in the history, the economic incentives don't work anymore. And in that point, yeah, we're screwed. So that's right. We cannot see that in front. So hopefully it works. If not, we are betting on the wrong horse.
Hi, what about the live hacking announced on the program?
I've seen at other conferences that some hacking against blockchains weren't discouraged or like weren't encouraged. I've seen some really negative feedback against live hacks. Some really negative feedback, so I decided against that after I wrote up for that. Sorry for the clickbaiting, I guess. No, like really, guys, I really tried to show you something and then decided against that. I was actually trying to show the transaction malleability live hack, but to be concrete, like at the Breaking Bitcoin conference, there was a live hack, and afterwards he got kind of really harsh feedback from the community that he was attacking Bitcoin and shit like that. So I try to get out of that. Usually I try to get out of the political discussions of Bitcoin and focus on the techniques. So I'm not doing that. Sorry.
On a technical level, would your live hack have worked?
Sorry?
On a technical level, would your live hack have worked?
Yes. Yes. So, if you wanted to know, like, it's... yeah, it was transaction malleability against Bitcoin, and it was putting inside the PubSig script, putting opt-up code, extra opt-up code, and afterwards opt-drop code. Yeah, that was the transaction malleability, and it still works today if you don't use Segwit.
Have you considered combining more than one attack of those you were describing? Like using a spam attack and another one on top of it?
A little bit louder, please.
Sorry. I mean, have you considered using more than one attack vector for achieving an attack?
That's an interesting point.
Like you could like DDoS the pools. Okay, if you DDoS the Bitcoin pools, the hash rate goes down. So 51% attack is much cheaper.
That's a valid point. The intention of this research is actually not to find new attack vectors or to break Bitcoin. It was at first to find why the blockchain protocol is vulnerable, and after that, describe a protocol level or define any kind of standard that withholds the most attack vectors. That is like the fundamental research that needs to be done, in my opinion, to go anywhere near a standard. What attack vectors work, because of what reason, so how should be a standard described that is kind of, battle tested or kind of good to go on with. And I have to say, this all excludes any use cases or any political or any, like he described, any economic incentives. This exclude all of this. This is just a technical security research. And it's just one way to approach this standardization process. The community can do whatever they want with that. So.
I would like to ask if we heard the Ethereum is planning to switch to consensus.
Yeah.
Do you have information on what's your opinion? Is it going to be as safe as it is now, or?
I heard this like 2 years ago as well. So I hear a lot of stuff. Up until I see any code, I cannot judge this. Sorry.
Yeah, you brought up the topic of standardization in cryptocurrencies, and I had a discussion with Bitcoin core developers some time ago, and their consensus was basically we can't standardize Bitcoin properly because, we need consensus between all nodes, and if the standard gets something right, the standard has to be amended because of all the old nodes. And we basically have a standard implementation and not a formal standard. What's your opinion? Can we change this, or do we have to stick with this?
I would say that's a political question, since the Bitcoin core standardization is a hard one for me. This is about blockchain standardization, not about Bitcoin standardization. The Bitcoin standard is de facto the Bitcoin core standard up until today. And I don't want to deep dive into that one. Sorry.
Yes, hi. The attacks that you're talking about, I think that they're not really comparable to other security attacks, because when they're protocol attacks, then you're broadcasting them in the network. So in my opinion, you can maybe for a short time disturb the network in some way, so lower the efficiency. But in the long run, if it's a big network and there are many people on that network, then they will identify your protocol flaws, and then they will kind of fight back or change something. I mean, like, you cannot carry out this attack without other people on the blockchain noticing this.
Yeah, but isn't that true for most security attacks? That you eventually get identified and they will try to shut you down and end your attack and try to chase you afterwards. So if there's attack ongoing and they reveal it very early in an early stage, you will fail. And if you get into a database and stay there for a long time, your profit will rise. Like I heard that some guys got into LinkedIn database and stayed there for 2 years, so because they went undetected. So if the question is for detection, right, the blockchain community has probably the ability to detect an attack vector or an attack in the early stage. The probability for that rises, actually, yeah, since it's an open blockchain, and since it's an open network, that's true. Yeah.
What do you think about the security of Bitcoin pre-SegWit and after SegWit? Now that the signatures are separated from the block, is there extra attack vector for that? And that not all nodes are required to keep the signatures?
That's again like a political question. But just no. Can we talk about this later?
Okay.
Yeah, like I'm getting filmed and it's not gonna be on the internet. Cool, thanks.
Okay, some more questions? So maybe I would have one too. So Tim, so you mentioned that there are a couple of different like consensus mechanisms. So is there any that you consider to be most/least secure for public blockchain?
Proof of work. Proof of work is the way to go, and I haven't seen any other consensus algorithm that works good if the premise is that we want a decentralized system. If that's not a premise, then there might be other good solutions. For a decentralized Byzantine fault tolerant system, I would always suggest proof of work today.
Okay, and maybe are there any innovative kinds of consensus mechanisms that you like know of? Like they are not so common, usually implemented in the public blockchains. Do you know something interesting in this regard?
Some secret horses. Sorry, no.
Okay. So, any more questions? Yeah.
Can you talk about the botnet attack?
Sorry?
Can you talk about the botnet attack?
Oh yeah, lovely. Like there were some guys researching this, and the idea is that so you have like a malware and you spread it, and like condition is that you have some mechanism to spread that, and via mail or whatever, your favorite porn site. And so you got some infected machines and they have your malware and they execute it. Inside that malware is like a Bitcoin client, also a client that connects to the Bitcoin network. And as well, hard-coded your public key, your Bitcoin public key, okay? So what you do next is you send some transactions on the Bitcoin network, and inside a Bitcoin transaction, there is some script executed, and the script is actually why people call it programmable money. Like that is the way I send you money, or I defined it as a multi-signature transaction. So whatever, there is one function inside the script, and it is called op return. And inside the op return, you can store some data. Okay, and you store inside this data, you store the commands for the bot. Okay, and so you push out a transaction, the bot just listens for the public key, and he knows, that's a transaction for me. He goes for the op return, takes the functions, and he has got some decoding mechanisms. This function goes for, okay, whatever, I get a new command, I get like, I get this data from here, over there, like fetch some data, get some data. So all the commands for the bot are encoded here. And you can use any bot out there with their existing commands and their existing command and control structure. And so what you basically did is, like a usual botnet is made up, I am the command and control server, and you are all the bots I control. So what the FBI usually does is kill the command and control server, the central part, cut it off, and then it's all dead. And essentially the Bitcoin network becomes your command and control server. They cannot shut down Bitcoin, or they haven't been yet. So that's kind of sneaky, I guess. And there's actually a proof of concept for that. They call it zombie coin, and they pulled it off. So there's the botnet via chain code attack, I call that. And I love that one. That's cool. Yeah. Thanks for the question.
More questions? Okay, so maybe I will have the last one again. So regarding the 51% attack, so there's something that I always encounter in the discussion about it. So there is like maybe sometimes misconception, like what actually an attacker conducting a 51% attack can do and what he cannot do. So can you elaborate on that a bit?
He can change anything in a block. He can reject blocks, meaning he can reject transactions. So that's basically what he can do. He can change history, and he can manipulate future, or like have an impact on the future. If you control the network, you can decide what the chain will look like. You can decide what is truth in the network, and truth in the past and truth in the future. That is his power. Yeah.
So you think that 51 is enough to control the network?
Yeah.
Okay.
I won't say that this is like a realistic attack for Bitcoin, because as soon as we'll see somebody pulling off a 51%, then the economics of Bitcoin won't work anymore, and people will dump their Bitcoins. But again, this is like an economic discussion for Bitcoin, and not like a technical discussion. And like I said, I want to get out of political and economically discussions, because I'm not really, I don't know too much about these topics, so I just stay out of them. But technically, yeah, it's possible.
Okay, thank you.
Yeah.
So, any other questions? If not, so please one big applause for Tim.